Alright, so as promised, a video to go through the example on page 375, so you can read along there if you want, and I'll just talk you through it as well. So first of all, we'll just read through the question and underline any important information. So the first sentence there just telling me what's happening. The student used 100 centimeters cubed of 1 molar nitric acid and 100 centimeters cubed of 1 molar sodium hydroxide. So that's telling me my volume. My initial temperature was 15.6 and my final temperature was 22.4, and I'm given the specific heat capacity and I'm told what the density is equal to, and my question is asking me to calculate the heat of neutralization. So my heat of neutralization, I should know my formula for that. Heat of neutralization is equal to the mass times the specific heat capacity times the change in temperature. So delta is the symbol for change, so I'm just writing it out shorthand here. So first of all, let's have a look at what we've been given in the question. So specific heat capacity, I know straight away, is 4080. I can calculate my temperature change very easily as well. It's 22.4 minus 15.6, and that gives me a temperature change of 6.8 degrees Celsius, which is equal to 6.8 degrees Kelvin. You don't need to convert here because the change is going to be the same. It's 1 for 1 there. And finally, my mass. So your mass here isn't given to you directly. What we do know is that the volume of solution that we've got, the volume of our mixture, is 200 centimeters cubed, because I've got 100 of the nitric acid and 100 of the sodium hydroxide in there. And I know that my density here is important. My density is equal to 1 gram per centimeter cubed. So what that means is I can convert centimeters cubed to grams in a 1-to-1 ratio. So that tells me that my mass is 200 grams. And of course we know that we need to match up our units here. My units for specific heat capacity are joules per kilogram per Kelvin. So I've already matched up my Kelvin here. It's the same as degrees Celsius. My 200 grams is equal to, I need to convert it to kilograms, is equal to 0.2 kilograms. So then we can slot all of that into our formula over here. So heat is going to be equal to mass, 0.2 kilograms, multiplied by the 4080 specific heat capacity, multiplied by 6.8 Kelvin for the change in temperature, and that gives me a value of 5,548.8 joules. So if we look here, multiplying specific heat capacity by mass will get rid of my kilogram unit. Multiplying by temperature change gets rid of my Kelvin unit, so I'm left with joules left over. So that's my unit there. So that's 5,548.8 joules is released by the amount of nitric acid that we have there. So how many moles of nitric acid is producing that? So number of moles of HNO3 nitric acid is equal to the volume times the molarity divided by 1,000. We're well used to this calculation now. Our volume was 100 times the molarity was 1 divided by 1,000 is equal to 0.1 moles. So 0.1 moles of the nitric acid produced this much heat. So now we know that our heat of neutralization over here that we're being asked for in the question, we know that that's always in or per mole. So we'll just continue on down here. So if we've got 0.1 moles producing 5,548.8, joules, how much will 1 mole produce? And the way we do that is to get from 0.1 mole to 1 mole. What do you have to do? You have to multiply by 10. So that means I have to multiply this value by 10 to find how much energy or how much heat is produced by 1 mole. And of course the answer to that is 55,488 joules. Now, our heat of neutralization and is given in kilojoules. So to convert that to kilojoules, there's 1000 kilojoules in 1 joule. So we need to divide by 1000 here, and so that gives us 55.488 kilojoules. So that means that that's the amount of heat produced by this neutralization reaction. Now, they want us to give our answer as a delta H value. So our delta H value, the heat produced is 55, sorry, there's a point in there, it's hard to see, 0.488 kilojoules per mole. So it's 55.488 kilojoules in 1 mole. And so our answer then is the heat, that's the heat produced. So it's an exothermic reaction. So that means we must put a minus sign in front of it. Remember, all neutralization reactions that you're going to see are going to be exothermic. So we give our answer with a minus sign in front of it.